We're going to dive into part 2 of the stoichiometric calculation. If you haven't done so already, make sure you check out part 1 before you coming into part 2. So let's begin by doing this example. What mass of sodium hydroxide, NaOH, would be required to produce 16 grams of antacid milk of magnesia, magnesium hydroxide, MgOH2 by the following unbalanced equation? So the following is an unbalanced equation, and very first thing we need to do when approaching stoichiometric calculation is to balance the chemical equation. So here we see a chemical equation, and I see the most complicated one looking one is magnesium hydroxide. So there's 2 of hydroxide, and on the left hand side I only see 1 hydroxide. So therefore I'm going to introduce the coefficient 2 in front of the sodium hydroxide to accommodate for the amount of hydroxide. Now there are 2 sodium on the left, meaning that I need to have 2 sodium on the right. I have 2 sodium on the right and 2 chlorine on the right. But you could also see that there are already 2 chlorine on the left, 1 magnesium, 1 magnesium. So it seems like now it's finally balanced. Number 2, it says to write the given amount as the starting point of the stoichiometric setup. My very beginning amount was that 16 grams of magnesium hydroxide. So 16 grams of magnesium hydroxide. I want to have a ending product, and I'm going to leave a room here, and my ending product unit would be the mass of sodium hydroxide. So what unit would that be? I'm looking for mass. That would be grams of sodium hydroxide. The grams of NaOH is what I want in the end. So I need to go from grams of magnesium hydroxide to grams of sodium hydroxide, and something needs to happen in between. To get into the between, number 4 is to set up a pathway to get to the product. So where is my pathway going to come from? It's going to come from these stepping stones to get to the ending. I could already see I need to have something involvement of grams. So I am going to utilize this one. Why? Because we have the grams on the bottom, and over here we have grams on the top. Grams of what? Grams of the molar mass of magnesium hydroxide. So here, grams of magnesium hydroxide, which we can calculate that from the periodic table. For every 1 mole of magnesium hydroxide. You might wonder, well, why don't you use some other mole number? It's limited to 1. If you look at the stepping stone, it says 1, so you could only do 1. No matter what the unbalanced equation or the balanced equation says, you go by what the stepping stone says, which is limited to 1 mole. So every 1 mole of magnesium hydroxide, how many grams of magnesium hydroxide will be there? You will need to calculate the molar mass. Calculate the molar mass and come back and check the key. So here is the molar mass of it. Okay, next. I want to cancel out the magnesium hydroxide since they're both same units here and this one. I can cancel that out. I have moles of magnesium hydroxide, which I can get rid of by utilizing mole to mole ratio. Why do we even want to get rid of a mole? That's because we want to change it into moles of sodium hydroxide. Our goal is to get from magnesium hydroxide to sodium hydroxide. So the only way to do that is to do the mole to mole ratio. So based on the balance equation, every 1 mole of magnesium hydroxide, there are 2 moles of sodium hydroxide. See the coefficient in front of the magnesium, And here is my sodium hydroxide coefficient 2. So I can cancel out the mole to mole ratio, moles of magnesium hydroxide. Not quite done yet because I want grams of sodium hydroxide, not moles of sodium hydroxide. So I want to get rid of those moles. And you can see the next stepping stone will be grams per mole. So every 1 mole of sodium hydroxide, you'll need to calculate the molar mass. And I'll just go ahead and give you the molar mass for now. This is 40.00 grams of sodium hydroxide. In the future, you're going to have to calculate that on your own. So let's do this calculation. I'm going to go ahead and start off with my 16, multiply by the 1 here, and then I multiply by 2, then 40.00. Hit enter. So everything on top multiplication is 1280. Then I'm going to divide it by everything that's on the bottom. So I'm going to hit division, open up a parentheses. Don't forget those parentheses. 58.32 times 1 times 1. Now, you might wonder, why do we need those parentheses? We might have a number different from 1. We might have 2 or 3, but please get used to introducing a parentheses when we're doing division for all the components that's on the bottom. And everything on the component on the bottom are these. Okay, and then so let's go ahead and then press enter, and I get 22. So why 22? You need to have 2 sig figs. So I'm going to go ahead and put 22. 22 grams of sodium hydroxide is the amount that it requires to produce 16 grams of magnesium hydroxide. So you're going to do a similar problem and come back and check the key. And here is the key. Next example, how many NH3 molecules are produced by the reaction of 4.0 moles of calcium hydroxide according to the following balance equation? They're not asking for moles, they're asking for molecules, so it's a little different now. And this is already balanced equation, so we don't need to deal with anything balancing in the equation. It's the same step. We balance this chemical equation number 1, but it's already done, so I'm going to move on to number 2. Write the given amount as a starting point. What is the given amount? Right now, the given amount is the 4.0 moles of calcium hydroxide. So I'm going to write that down. 4.0 moles of calcium hydroxide. And then number 3, it says write the unit of the ending product. What are we looking for? We're looking for molecules of NH3. I'm going to put right here equal to some number molecules of NH3. Number 4, it says set up a pathway to get to the product. All right, so we have moles of calcium hydroxide now, but we need to somehow change that so that it needs to deal with ammonia instead, the NH3 instead of calcium hydroxide. The only way to do that, to get switch from one molecule to the next, is to follow the mole to mole ratio. So therefore, multiply by every 1 mole of calcium hydroxide. How did I know it's 1 mole? It's because in front of that calcium hydroxide balance equation, there is 1. And for ammonia, however, you see the coefficient as 2. So you're going to write 2 moles of NH3. Our temptation is to end here because, okay, I have moles, so therefore I have everything I need. Moles of NH3. I'm not looking for moles of NH3. I'm looking for molecules of NH3. They're different. So I look at the pathway again. Which one deals with molecules? It deals these 2 big ones. I'm going to choose the very first one, and that's because the mole is on the bottom. So I'm going to write, and it's limited to 1 moles of NH3. And the top, it's a big number, 6.022. We have our Avogadro's number, molecules of what? Of NH3. So now we can cancel out all the units, and you'll see that it's left with just molecules of NH3. So moles of calcium cancels out, moles of NH3 cancels out, and I'm left with molecules of NH3. So let's go ahead and put this in our calculator. 4.0 times 2 times all that big Avogadro's number, 2 times 10 to the 23rd, and then I hit enter. So I have some big number here, divided by 1 times 1 with the parentheses. It's going to be the same number, but we're practicing. So it's 4.8 times 10 to the 24. So the final answer is 4.8 times 10 to the 24. I'm going to squeeze that in there. Molecules of NH3. Please read this particular question and try to solve it on your own and come back and check the key. So I actually haven't written out the actual answer yet, and this is because I want to show you how to calculate this if you were having some issues. First, the explanation of the setup, then let's get to the calculation. So I took the molecules of calcium hydroxide, the Avogadro's number, and placed it here to cancel out the molecules of calcium hydroxide. Then I used the mole to mole ratio to get to the moles of NH3. Finally, I used the molar mass to get to the grams per mole to get to the grams of NH3. And that's what I'm looking for. I'm looking for the grams of NH3. Let's get into the calculator. So I'm going to go ahead and punch in the 8.332 times 10 to the 24 with the parentheses. It's a very large number. 32 times 10 to the 24. Okay, I'm going to close that parentheses now. Then you can hit enter. I recommend you doing it, or you could just let it be. If you let it be, you must have the parentheses. If you you must let it, if you want to let it be and continue on, you have to have that parentheses present. Multiplied by 1, multiplied by 2, and then multiplied by 17.04. So I'm basically getting everything that's on top. Hit enter. Now hit division sign. Now I have this big Avogadro's number with the rest. I mean, what if the rest of the number wasn't 1, it was something else? Then we need to think about that. So I'm going to put in, instead of 1 parentheses, double parenthesize. The second parentheses is to encapsulate the Avogadro's number, and then close it, and then multiply by the rest of the moles number, and then I'm going to close it. And that's the one that encapsulates from the beginning. Okay, hit enter, and I get 471.5 grams of ammonia.